Hi, welcome to another episode of Ask the Expert. Today we're talking about wideband ultra-low power Wi-Fi. Joining us today is Graham Smith from Infineon to answer questions about the market's lowest Wi-Fi Bluetooth module CYW43012. Hi Graham, welcome to DesignSpark.
Hi Greg, thanks very much for having me.
Graham, the CYW43012 is the lowest power Wi-Fi module available. I'm intrigued by the partial compliance with Wi-Fi 5, where you support 256 QAM on a 20 megahertz bandwidth channels in a 5 gigahertz band. Could you take us through the reason why you've included this on the device?
Yeah, of course, yeah. So the AC friendly, which is a trademark of Infineon, that solution is designed to address a particular market type. So obviously Wi-Fi is ubiquitous. You see it in phones, tablets, PCs, wearables everywhere. And one of the main sort of headline features of every new Wi-Fi specification or release is speed and throughput. You know, everyone seems to be driving towards higher end throughput or faster speeds. Now, that's important for a lot of customers, especially those who are, say, streaming video or audio or have a high data bandwidth. But in the IoT and sensor type spaces where the main requirement is to send small chunks of data infrequently, and they don't need the 1480 megahertz channels that the full Wi-Fi 5 or 802.11 AC specification provides. So for those sort of customers, what we've done with the AC friendly solution is offer the benefits of 256 QAM. So you get the better encoding modulation schemes. But what we do is limit it to 20 megahertz bandwidth channels. And essentially what that allows customers to do is to send the data as efficiently as possible using that quadrat amplitude modulation scheme. At as lower power consumption as possible, and that's one of the benefits of the new 28 nanometer process. And then put the device, either the radio and or the host MCU typically, into as lower power mode as quickly as possible. The other sort of benefit of that, the 43012 device, is that in the past a lot of customers have seen very basic requirements just using 2.4 gigahertz. They haven't looked at the 5 gigahertz spectrum.
Yeah.
And there's a kind of perceived move to 5 gigahertz for future compliance. There's some fears that maybe in 5, 10, 15 years time that there might not be a 2.4 gigahertz access point they can connect. It might only be 5 gigahertz. Yeah. I don't necessarily believe that will be the case, but it's always good to be able to give yourself the option of being able to connect to either or. And obviously, as we get more and more IoT connected devices, that 2.4 gigahertz space gets more and more crowded with either Bluetooth peripherals or over ISM band sort of operations. So it's always good to give yourself the option of using a clear channel wherever possible. And fortunately, the 43012 allows customers to be able to do that. So we're very happy, very positive. It's a real game changer for our customer base.
Yeah, I was just wondering the reason why you were moving from 2.4 to 5. I guess that was reason is to future-proof using that new process.
Yeah, I mean, I don't necessarily believe that we're in a short-term danger of 2.4 gigahertz going away. But there are, if you're an industrial customer and you want 10 years product, to sell, and then it could be deployed for another 10, 15 years beyond that. Having the option to be able to connect to multiple different frequency bands, it just gives you that little bit of peace of mind that whatever happens, whatever might come next, at least you're going to have some way of being able to connect, even if it does require your customers to potentially reconfigure and change the bands. It's a lot easier to do that than it is to send somebody out to the field to change the unit because all of a sudden their access point that they're getting from their ISP is no longer connectable to their device. So yeah, I think it's definitely nice to have. And we're definitely seeing some advantages, especially from a power consumption perspective, that the 5 gigahertz can offer.
Okay, so just following on from that question, could you give us any kind of real world examples where that kind of power consumption you've seen in existing IoT applications that use that technology to, for example, periodically burst data on 802?
Yes, I can. And if it's possible, I'd like to share a quick slide that could hopefully explain this in a little bit more detail. So hopefully this comes out okay. Now, this is a real world comparison against actually one of our own devices or two of our own devices. So what we tend to see is in transmit mode, you see typically a 25% reduction in power consumption compared to a 40 nanometer Wi-Fi 4 or 802.11n. terminology is still a little bit interchangeable. So that's that's obviously nice to have. Where the big benefits are for customers is in the receive mode. So if you compare it to, again, the same 40 nanometer Wi-Fi 4 solution, we're seeing in the region of 50% reduction in power consumption in receive mode. And if you look at if you compare that to one of our full Wi-Fi 5 or 802.11ac solutions, it's in the region of a 70% power consumption reduction. Now, that makes massive difference to how you can architect your solution, what you can do from a battery power perspective. And that's just in transmit and receive. The other sort of benefits of the new device are we've obviously improved the sleep and the low power modes even further. So sleep consumption is reduced by approximately 80%. And then what we term idle and ready modes, so they're that it's not in sleep, but it's not actively transmitting or receiving, they're in the region of 50 to 60% power reduction. Now, what that translates to from a user perspective is if you were using one of the Cypress devices, a 4343W is what we use as, which is a 2.4 gigahertz only solution. That would typically get around 150 days of battery life from just over a 1500 milliamp hour battery. If you just did a like-for-like comparison with the 4302 and just use 2.4 gigahertz and just use deep sleep still, you'd nearly double in that. So 320 odd days of battery life from the same battery. Now, obviously that's a big step change. But if you could actually utilize the 5 gigahertz and some of the enhanced deep sleep modes, you can nearly triple your battery life compared to what you were doing. Now, that's a real sort of change for battery powered applications where they've not been able to, Wi-Fi's, we dabbled in the past as being a battery powered solution, but it's not really been really capable of having a long lifetime. You don't want to have to send service engineers out every 6 weeks to change your battery solution.
Yeah.
Because that's not what you want to do. You want to have it, work, last, and be forgettable. The other thing that we don't really touch on is the fact that we forget this is a combo device as well. So it's not only Wi-Fi, it's a Bluetooth solution at the same time, and it supports Bluetooth Low Energy and Bluetooth Classic. And we've seen similar power improvements in the BLE perspective. So we're talking average power consumption reduced by about 50% in BLE mode, and similar in BT Classic as well. So for low power applications, and you see there's a lot of this sort of focus on how we reduce power consumption in total. A lot of the sort of use cases is BLE is the main sort of connectivity mode. Bluetooth is typically always lower power anyway, but you're connected 90% of the time in Bluetooth, and then it's only when you need to send either cloud connected data or you want to do over the air updates, or you've got a big chunk of storage data that you need to transmit, then you turn on the Wi-Fi, send it as efficiently as possible, and then go back to your low power modes. So the 4302 is an ideal solution for those sort of environments and architectures.
That's really interesting, because I was talking to one of our partners earlier today, and one of the applications that they were talking about was they need to have very good battery life for remote location, because the cost of servicing for battery replacement is really substantial. So this sounds like it's a great solution for reducing that cost of servicing, and which is also a great benefit to anybody using these types of products.
Oh, definitely, and it's you got the servicing improvements, but also the general sort of impression and product awareness and feel of your company's products. If you design a smart doorbell and you're changing the battery every 2 weeks or 3 weeks because it's doing lots of video streaming and it's going to and it's running the batteries down, people are going to think, yeah, it's quite nichey, it's quite fun to have at first, but they're just going to get frustrated with it.
Absolutely.
And that brand experience is going to be very poor. Whereas if you put something on there and it lasts a year, 2 years, people forget about it. If anyone asks, to go, oh yeah, never even thought about that. And that's great for consumer products. But you say for the industrial products, or you look at metering type applications where it's put in the ground, it's left alone, it's not touched unless it's just be meter read, for example. That could be 10 years. And whilst in typical use case, we're looking at 3 years. You can obviously optimize that to, if you can really periodize the connectivity model, you can get better than 3 years as a typical example. Yeah. So,
right.
So yeah, so it's good for that.
Could you take us through some of the specs and the software you have available for your integrated ARM processors and a wireless LAN subsystem and Bluetooth subsystems?
Yeah, of course. So inside most of our combo devices, you'll typically find there's a a Cortex-based processor for the Bluetooth subsystem, typically either a Cortex M3 or a Cortex M4, depending on which generation of product it is. And then for the wireless for the Wi-Fi subsystem, it's typically either a Cortex M3 or a Cortex R-based processor. And again, a lot of that's generation of device based and throughput based. Now, in the past, those cores have been typically utilized for doing the lower level PHY control, radio calibration, actually making the data go. So how you send the data you want to send over the physical medium of Bluetooth or Wi-Fi, and you don't typically have user access to that. In 99% of applications, you've got either an A-class processor if you're doing a Linux type solution, or a Cortex M based solution for RTOS-based solutions, and that typically runs all your TCP/IP stacks, has your application code, and how you actually create your product. What we've been trying to do as we move forward is work out what features and new things we can put into that the processor that sits on the radio device itself. So that could be feature upgrades, so things such as WPA3 support for some of the newer devices. It can be bug fixes or security fixes. We're all aware that people try to hack these products as much as possible, so it's important to be able to update the security as you roll over a product's lifetime. But what we're also trying to do is move towards having user application functions or host offloads put into those devices. So things such as TCP keep alive, ARP offloads, stuff like that. And then what we're trying with the moment is looking at how we can utilize typically the M-class processors on the Bluetooth subsystem to be able to do extra things. So the 43012 is a great example of where we've thought about the architecture from the start and looked at operations that we could potentially run completely on the radio device. So the example in our current Modus Toolbox software IDE, which is an RTOS-based tool essentially, is you can run all of your BLE application code on the M4 core that's inside the 43012. So it could be a simple peripheral with a typical number of profiles or custom profiles for exchanging data, and only when it really has to signal the higher end host processor to wake up, or say it needs to then connect to the cloud, and kick the host processor into active mode to start Wi-Fi transmission and stuff like that. The longer term plan is to move towards what we call a cloud connectivity manager, or CCM solution, which you may see on some of the roadmap slides in a bit later on. And what essentially that does is take more of the Wi-Fi application and put that onto the M4 core as an example inside the 43012. So that's running very low level TCP/IP stacks, TLS solutions, and some of the other lower level functionality. And then again, when that really needs to, it can then wake up a host process to do something more powerful or more throughput intensive. Now, I'd like to say that's generic across all products in the Infineon portfolio. It's not there yet. We've started it with the 43012 because it's a newer device, but it's something we'll certainly be looking at for any new devices moving forward. And it's something we're trying to push as many of the offload features into the radio cores with every new product launch we do. So it's a work in progress, should we say, but it certainly gives users a different option that they can sort of utilize moving forward.
Okay, I'd just like to ask about Bluetooth 5. As well as a higher speed, it incorporated the 0.9 mesh networking standard. Is there any software to help people develop mesh applications such as retail beaconing apps, for example?
Yes, that's a simple answer. Typically, what you find in a mesh node is that you have one gateway node that will have Wi-Fi and Bluetooth, and obviously push data or pull data from a cloud-based application. And then the individual nodes or the individual members of that node will typically be BLE or Bluetooth-only sort of solutions. Now, what we have as Infineon is two devices that are ideally well suited and developed for this type of application. So we've got the 20819, or I should say for full completeness, the CYW 20819 and the CYW 20820. It's a bit of a mouthful, that one. And what essentially these devices are, if you looked at the M4 core of the CYW 43012, it's essentially that same architecture pulled out into a standalone embedded device. So it has ROM to host the stacks, it has flash for your application codes, SRAM, but the actual radio sort of device is identical to what's in the 43012. Now, the difference between the 819 and the 820 is essentially output power. And for mesh applications, a lot of that depends on what their role is in that mesh. So if you're a relay node or a proxy node and your main's powered, if you can have higher output power, you can basically increase your coverage of a given area with a single device. So the 820 base version has a 10 dBm output power capability, so that can give you a much greater coverage of a room space or a building space than the 819, which is a 4 dBm output power. The trade-off for that is obviously power. So again, if your main's powered or you have access to a higher ampage battery, then 10 dBm is brilliant. But if you're really going to be a low power edge node and you're only reacting once you sense something, and that's the only time you really want to connect to the network, then the 4 dBm output power solution is typically a much better fit for that. Now, obviously, it's great having hardware, but you need to be able to develop applications easy for this. And this is where our Modus Toolbox IDE and SDKs come into themselves. Now, the IDE is essentially an Eclipse-based tool. You can use other third-party tools, like Visual Studio Code and things like that as well, but we try to limit support to, or try to functionalize the support into the IDE itself. And that has something like 50 or 60 different examples that you can run in an RTOS-based environment for the 819, the 820, and the other devices in our portfolio that support mesh. So that's from basic on-off servers and clients to temperature sensors to humidity sensors, PIR type sensors for motion detection. And that's essentially sort of giving you the ability to either act or react to something, or to be able to sense and transmit that data through a mesh. So it might be that your example doesn't really need temperature sensor, but it's an ambient light sensor. Well, you can modify what the data content is, but it gives you the ability to get up to speed quickly and implement those. It also supports things like OTAs, so for giving yourself an over-the-air update and provisioning tools. Now, if you do for the gateway type applications, the support's a little bit different. So a lot of gateways are Linux-based, and the host stack for Linux is typically BlueZ. So BlueZ has support for mesh provisioning and GAP proxy modes. And what that means is, obviously, the provisioning side is relatively self-explanatory, but the GAP proxy is how a gateway device connects into the mesh. It doesn't act individually as a mesh node. It almost forms a peripheral client connection with a particular device to be able to get data in and out. So for those type of applications reliant on third-party tools, BlueZ's provide a tool called Mesh Control, which allows you to go through and create, provision, do everything you need to do. For RTOS-based solutions, we're actually just at that inflection point of offering a solution that would reside inside Modus Toolbox as well. The aim there is, again, is the same support for provisioning and GAP proxy connections, and we term that's part of our any cloud solution, which is what our terminology for anything that doesn't require Embed OS or Amazon FreeRTOS for secure onboarding. Now, as I said, that's not currently in the public release of the SDK, but we hope to have it rolled out by the end of the year. If you need something now, please reach out to your local Infineon FE or sales contact, and they should be able to provide you something that would get you started, at least with the evaluation process.
Okay, yeah, I was going to ask about Linux and Android-based applications and also RTOS. So do customers need different parts, or what support is there for all of those areas?
Fortunately for at least my terminology and remembering part numbers, they don't need different parts at this particular moment in time. We try to sort of focus on the hardware capabilities of the device only from a part numbering perspective. But what we do have is different release models. So for Linux-based solutions, we aim for a quarterly release schedule. And that's typically either pushing new features or security fixes. And so things such as WPA3 support and the security fixes being sort of 2020's sort of focus. And that's fully documented. We have a complete package which we host on our community site, and that's community.cypress.com. And essentially on there you can find information how you do backporting if you're using a different Linux kernel version, all the FMAC drivers you need, and all the different binary files for the firmware and the CLM tools for country locale matrix, so how the actual radio works. So that's all provided on there. We also have a Yocto build. This is something that's been relatively new to Cypress. We've never particularly given Cypress and Infineon, I should say, we've never given particular focus to Yocto in the past. But what we've now done is provided a dedicated Yocto build process, again with documentation and tools on how you utilize that, take that, do your own implementation if you want to do that as well. For Android, we're starting to see a migration from Linux to Android for a lot of applications. And again, we currently support Android 10. We have a technical brief that we do every quarter with every release as well. So it's a similar sort of process for the Linux builds. But again, that's all documented on the community page. It's a lot of information to try and explain verbally, but if you we'll post some links at the end of the chat to
absolutely, yeah, we'll definitely put links. Yeah, definitely put links. Yeah.
For the RTOS-based stuff, it's a very different solution. So we touched on Modus, which is our tool chain that we use for building these solutions, and essentially what that has as its core is what we call our Wi-Fi host driver, or WHD. Now, Modus focuses on using one of the Infineon microcontrollers, the PSOC6, as a host device for all of our radio applications. That's the holy grail for us as Infineon people. Is we want you to use our host MCU and our radio device. But the reality in the real world often comes back to strike, and we realize that there are a variety of different other MCUs out there that people are going to want to use and want to support. So things such as ST or NXPs, architectures are the most common ones we see alongside PSOC. And what we've done is try to abstract that WHD or the Wi-Fi host driver into an exportable sort of package that you can pull in alongside some hardware extraction layer tools and some network interface tools into things such as MCU Expressor or STM CubeMX for working with those solutions. And what we started with doing is we've host and post the WHD source onto GitHub. So if it doesn't support a particular MCU that you want, we at least give you the ability to take a known package, a known release, and go and build it yourself. But I'd highly advise any of your listeners or viewers to look at the PSOC hosts. There are some benefits to using a two-chip solution from Infineon, so we can do some optimization for our own host micros as well that won't be possible with third-party tools as well.
Okay, great. And how do you support customers during their test and certification? Can they reuse your certifications, for example?
The short answer is yes and no. A lot of it depends on what they're trying to certify and where they're trying to certify for. So typically, as a company, Infineon don't focus on selling the Wi-Fi silicon. We try to use module partner vendors to get to market for customers, mainly because the certification design cycles for these sort of products are 8-9 months of testing, hundreds of thousands of dollars, and a lot of the time that makes the product inviable. So what we've worked with Murata, LED, Lantronix, and a number of other module partners to create either pre-certified or reference certified products that they can then, from an FCC perspective, for example, reuse the certification completely. From a CE perspective, they can at least reference some of the documentation. They still have to do some of the testing, but they kind of know it's going to pass if they haven't touched too much of the antenna chain as part of that sort of implementation process. Now, as part of that, the module vendors are responsible for providing customized CLM, country locale matrix blobs, specify what radio channel you can operate on for a particular country code. So if you want to be able to exclude channel 14 or only use 2.4 gigahertz and not 5 gigahertz, they've dealt with the regulatory compliance for generating that product. If a customer or a user needs something specific, they can contact Infineon. We have a regulatory tool and basically an Excel spreadsheet and template file that they fill in that says, I want to operate on these channels, these bands, this output power. We'll go away and we can generate a customized CLM specific for what they're trying to do. Now, that gets them up and running. They need also typically test tools. So we provide a manufacturing test firmware that they can program into the device. The one caveat I will say at this point is you cannot go to production with that manufacturing test firmware. It will completely invalidate any regulatory compliance or certification. So please make sure they utilize the production firmware, not the manufacturing test firmware before you ship your product. But that test firmware in cooperation with what we call a WL test tool allows you to put it into various TX and RX modes for emissions testing and performance testing and evaluation. We have a similar sort of process for Bluetooth as well. So we have Bluetooth manufacturing test tools such as CY Blue Tool that allows you to connect over HCI, UART, and control, configure, debug. We have a BT Spy tool, which is less cool than it sounds. Basically, collects HCI traces and BT Snoop logs. That if you do run into any issues, that it will be the first thing that an Infineon engineer will ask you for copies of, so that we can at least try to debug and understand what's been going on with your system and your architecture. And what we try to do is pull as many of these tools into the software tools as possible. So things such as Modus Toolbox will have certain tools built into it. And for the ones that don't or aren't compatible with that particular tool chain, there'll be referenced again on the community page with getting started guides, user guides, potential codes and commands you can control and configure. So it's not as straightforward as pure Bluetooth design, where you can literally be cut and paste and just reference QD IDs and declaration IDs. But we try to simplify the process as much as possible. And that's kind of why you see a reluctance to sell silicon directly, because we realize that all of a sudden, if you're taking a 316 bump WLCSB package at 0.2 mil pitch, it's really going to be difficult for a 10, 20, 30,000 piece unit customer to put that into production at a price point that makes it worthwhile. So the module partner and the module route is definitely a step forward and the right way forward in that particular architecture. Yeah,
it sounds like from a customer's perspective anyway, there's plenty of engineering support there for the guys to get on with. Absolutely.
Yeah, definitely. That's one of the big benefits of being at a company and working with a company like Infineon is we obviously have frontline support like the FVE teams that have direct contact with customers, but we have level 1, level 2, level 3 applications teams that can take common requests and common issues, and we'll either try to, if it's something that's happening time and time again, we'll create app notes or guides that will guide you through the process. But if it's a particular issue, then we do have the community page where you can post questions and you get a dedicated Infineon person will respond. And if it needs something slightly more confidential, or you want to share schematics or customer code, we do have the ability to make private groups, and we still have in the background a case system where we can create private cases as well. So don't worry about sharing your application code on the web. We do have ways of protecting that IP and knowledge as well.
That's great. That's fantastic. So, Graham, where do you see the direction for Wi-Fi for IoT going in the future? Could you maybe just give us a quick insight?
Yeah, Wi-Fi should be as simple as possible, and that's hopefully where we're going to try and get to with our software tools. And by being able to offer new features in hardware, that just makes it easier and builds on top of that. So that's kind of where I said divergence is probably the wrong phrase, but there's definitely going to be a switch between the really higher end solutions and the lower end, lower data rate, lower throughput requirements of the IoT space, as the marketing people like to call it. And I think we're well positioned as a company with product. Our software tools are world class, and what we need to do is get more people using it and get more awareness of these products, so that people can get up and realize themselves how easy it can be to add Wi-Fi to an application.
Great. I think from an engineer's perspective, you've certainly got a lot of the help facility there, but then also what you were talking about, time resources reducing, but then also with the low power extra battery life, there are lots of benefits there. So for me, it's been a great pleasure talking to you today to understand a little bit more about your ultra low power Bluetooth Wi-Fi. So thanks for joining, and we'll talk again soon, Graham.
Thank you very much for having me. It's a pleasure. Thanks, Greg.